All right, another type of compound probability deals with the OR situation. A probability of event A or event B happening. Now, if you think about it from our example of Mr. Wright, say we're interested to find someone who's just intelligent. They either have an A average or a B average. That is fine with you. So you are less picky in this situation. And when you're less picky, the odds should improve. So we calculate this the same way we did the earlier problem. The probability of A, the frequency is 910, divide that by 10,000 to total. Probability of a B average is 2460, divide that by 10. We get our two simple probabilities here, but in this case, in the OR situation, we add them together. So OR means add. And when we add them together, it increases our probability. It takes these smaller probabilities, add them together, and it goes up to 0.337. So that's what happens in the OR condition. We add our simple probabilities. There is one exception to this rule, and that has to do with something called a mutually exclusive event. In the situation, if things are not mutually exclusive, for instance, probability of an A average student or an attractive student, well, these are not mutually exclusive because both of these could happen in one student. The example we just went over, probably an A average student or a B average student, these are mutually exclusive. You cannot have both an A average and a B average at the same time. So these are mutually exclusive. We don't have to do anything else to this formula. But in the case of something that is not mutually exclusive, meaning these events could happen at the same time, we have to subtract out that notion. So it's not just the probability of A average plus the probability of being attractive. We have to subtract out the probability of being both A average and attractive. And the way we do that, since there's an and there, is to multiply. So we have this simple probability. We have this simple probability for attractive, and we're adding them together. But then we have to subtract out this probability of attractive times this probability. And that gives us a probability of 0.645.